Alright, in this video we're going to be discussing exponential functions, a little bit about their properties, and how we're going to find their derivatives. So we'll start by just defining what an exponential function is, which we'll put up here at the top. So an exponential function is written in the form f of x equals b to the x, where we have the variable x as the exponent value, and then b is just the positive constant. And just a recap of what this means is that if we have like 5 b values, say we have b times b times b times b times b, we could just write this as b to the 5th. So that's what the x value would represent as x equals 5. So f of 5 equals b to the 5th, so that means we have 5 b values for any integer positive that is labeled as b. If x equals 0, then b of 0 is always 1. So if x equals 0, b to the 0 equals 1. So anything to the 0 power always equals 1. That should be a little bit of review. And then if x equals a negative number, so if we have b to the negative x, so I'll just put that here. If x equals negative n for a number n, an integer n, then that means b to the negative n equals 1 over b to the n. So if you have negative in the exponent, it must be put on the denominator of fraction in order to evaluate it. And then if x is a rational number such that x equals p over q, if p and q are integers and q is greater than 0, we can write in this form. So if x is rational and x equals p over q, so a fraction, where p and q are integers and q greater than 0, because that's going to be on the denominator, then b to the x, which we defined x as p over q, equals b to the p over q, which can then be written as the root, the q root of b to the p. So that's, we have a p right here and a q right there. That's hard to see. Which we can also rewrite this as the q root of all to the power p. So that's another way you can write that. So those are just some general forms of exponential functions. And now we want to figure out how to take the derivative of them. So these are a little bit trickier than what you're typically used to. So the first problem we're going to look at is differentiate f of t equals negative 2 e to the t. So we know that this is a form of the product rule, which you should have covered earlier in Calc 1, and as such we'll treat it that way. So the negative 2 is the outer term, e to the t is the inner term. So we know that d dt of negative 2 equals 0, and then we know d dt of e to the t equals e to the t. So if we do product rule, derivative of the outer times the inner, so that's 0 times e to the t, so that just goes away, plus derivative of the inner times the outer, so that's going to be e to the t times negative 2. So f prime of t equals e to the t times negative 2, which you would rewrite as negative 2 e to the t. And you'll see that is the exact same thing we currently have there, because All right, for this next example, we're going to look at something a little bit more complicated, which is going to be same instructions of differentiating. This time it's going to be f of x equals 3x squared minus 5x times e to the x. Well, this is another product rule type of problem, except there's a little bit more going on. So that derivative of the outer, that's 3x squared minus 5x. That's what we're going to do the derivative of first. So d dx of 3x squared minus 5x equals 6x minus 5, and then it's times the inner, and then derivative of the inner, so d dx of e to the x equals e to the x times the outer. So we're combining this all together to get f prime of x equals 6x minus 5 times e to the x plus e to the x times 3x squared minus 5x. So at this point you see that we have a like term of e to the x. We have an e to the x term there and then another one there. So we can factor out the e to the x from the whole thing, and that just gives us e to the x times 6x minus 5 plus 3x squared minus 5x. And then we'll just combine all of this. So e to the x times 6x minus 5x, so that's just x. And then minus 5 plus 3x squared. And then to write this in the proper order, we would have e to the x times 3x squared plus x minus 5. And that'll be our final answer for this problem. So the next example we're going to look at is going to be differentiating this function, which we have f of x equals x squared times e to the x over x squared plus e to the x. So this is the quotient rule that you learned from Calc 1, but it's a little bit more complicated now that we have the exponents here. So we know that the differentiation of this is the bottom term, so x squared plus e to the x times the derivative of the top minus the top times the derivative of the bottom, all divided by the bottom squared. So if we write that out, so f prime of x equals the bottom term, so we're just going to move x squared plus e to the x, so all we're doing is taking that bottom term, putting it right there. And then that's going to be multiplied times the derivative of the top. And now we're going to take the derivative of the top, so d dx of x squared times e to the x, and it's easy to separate the terms out like this to keep it from being confusing. So this is just a small product rule, so x squared times e to the x, so that's going to become 2x times e to the x plus e to the x times x squared, which you can factor out in e to the x as a like term, and then just have that times 2x plus x squared. And that's the derivative of the top term. So we'll write that here. Okay. Now the next part is going to be the top, so that should be minus there. The top, so the top term is x squared times e to the x, and now times the derivative of the bottom term. So we're going to take the derivative of x squared plus e to the x, which is just 2x times, or 2x plus e to the x. And therefore, we'll put that right up here, 2x plus e to the x. And then all that is going to be divided by the bottom term squared, so x squared plus e to the x squared. And that is the derivative. And you are welcome to simplify that, however, it's not a necessary step. And what we have here works just fine. So it's basically two smaller product rules that you have to find, and then just putting the pieces together. Again, this should kind of be a review from Calc 1. The only difference here is with the exponents that you're dealing with. So the next one we'll look at is going to have the same instructions, differentiate. And this time we're dealing with f of t equals tangent of 1 plus e to the 2t. So this is going to be a little bit different with how we deal with e to the 2t, because now it's more than just a lone t value or lone x value right there. So remember, derivatives of trig functions is using the chain rule. So we'll do f prime of t. We know the derivative of tangent is secant squared, so secant squared of exactly what you see inside currently, so 1 plus e to the 2t. And then this is where the chain rule part comes in. Now we're just taking the derivative of what's inside there. So that's going to be times, we know the derivative of 1 is 0, and now the derivative of e to the 2t is e to the 2t times 2. So everything remains in the exponent, that 2t, then you take the derivative of the exponent, so the derivative of 2t is 2, and put that down on the side that you're multiplying by. So then we can just simplify this whole thing down to secant squared of 1 plus e to the 2t, and then 2e to the 2t, and that's our final answer for the derivative of this problem. All right, and the last one we're going to look at today is going to be differentiating f of x equals e to the sine squared of x squared. So an easy way to do this, because that's kind of a big term that we have there in the exponent, is we're going to let u equal sine squared of x squared, such that f of x equals e to the u. Now we know f prime of x equals e to the u times d dx of u, the derivative of u. So now we just want to take the derivative of sine squared of x squared, and we're going to let d dx of sine squared of x squared equal 2 sine of x squared, and then the derivative of sine of x squared. So this is the something that should be a review from Calc 1. So the derivative of sine of x squared is going to be cos of x squared times 2x. So we have that big long term, and now we're going to combine this all together, which we can rewrite as 4x sine of x squared times cos of x squared. And now we'll just put this all together. Remember, f prime of x equals e to the u times d dx of u. We found d dx of u right here. So d dx of u is this value right there. And now we just plug that back into our original statement that we had right here. So that leaves us with f prime of x equals e to the sine squared of x squared times 4x sine of x squared times cos of x squared. And that's our final answer for the derivative of this